So in this class, we will solve a truss problem using method of joints or method of sections. So in the earlier videos, I have explained about method of joints, wherein we are going to take a joint by joint and using two equations of equilibrium, that is for cochlear constraint force system, sigma fx0, sigma fy0 at the joints. We are going to solve for the unknown forces in the members. That means we can find out only two unknown forces meeting at a joint. That means only two members should be there at the beginning joint. Then later on we can take more than two members also. So that was the procedure. Now here, whenever they ask forces in only few members, then we have to go to method of sections. Here in this problem is a model question problem. Determine the forces in the members BC, GF and CG. So BC, GF and CG. So this is the truss given. Of course, it's a cantilever truss. You can take it as a cantilever truss or simply support it was horizontally. It consists of so many members subjected to loads 4 kN and 6 kN like this. He has asked the forces only in three members. That is important here. BC member, then GF member, and CG member. These three members. So you know that in the case of trusses, loads act in the joints, and also trusses consist of members which develop only axial forces. That is tension force or compressive force. And as we know, in the analysis of trusses, we consider tension forces as positive, compression forces as negative. So all this I have explained in the earlier videos. Initially, we will not be knowing what type of force will develop in the member. So we will assume tension force initially. Then we are going to apply the equations of equilibrium. And if the value comes out to be positive, force value comes out to be positive in the member, then it is tension force. If it is negative, it is compressive force. Now here, whenever they ask forces in few members of the truss, then we are going to use this method of sections. So this is solved using method of sections. In the case of method of sections, we can use all the three equations of equilibrium. That is sigma fx0, sigma fy0, and sigma m0 also can be used. Whereas in the case of method of joints, we are going to use only the first two, sigma fx0, sigma fy0. So here the procedure is, in whatever members they ask the truss, we have to take a section. For example, this xx is a section which cuts the members in which the forces are required. So here the forces are required in BC, CG and GF. So what I do is, I will take a section XX which cuts all these three members of the truss. Afterwards, we are going to take any one side of this section, either left side or right side. That means if I take right side, only this much I have to take. If I take left side, this much I have to take. So whichever is convenient for you, easier for you, you consider one side of the section and try to analyze the that side of the section, that part of the truss. You can take it as part of the truss using the equations of equilibrium. That means in this case, what I do here is, I have to analyze only right side. So consider the section XX which cuts the members in which the forces are to be found out. So in this case, of course, we can have a section like this. Suppose if they ask in some other members also, then you might have to go for one more section. So like that. So the number of sections depends on the number of members in which the forces are required. So here only three forces are required in three members. So since we have three equations of equilibrium, definitely we can analyze by taking a single section. Now what we have to do here is, so we have to consider this one side of this section. Now I will take right side of section XX and use the three equilibrium equations. So that means, in other words, we are taking the free body diagram of the right side of the section of the truss. So this part of the truss we have to consider now, and we have to apply the equations of equilibrium. So what we will do here is, so now this is the part. Now I will write only that part of the truss. So it is something like this. This is A. So B is here. This is 4 meters here given, and this is the section XX. Let us take this section as XX section, and this is G, and of course it runs like this. So only this much I have to take. This is of course C, and that means 1, 2, 3. So these three are the sections. These three are the members. This is GF, in which we have to find out the forces. Of course, he has given 2 forces here, 1 4 kN, another 6 kN acting at B and A, vertically downward forces he has given. Now, what we have to do is, let us find out this angle, theta. So, from the triangle, you can see that this right angle triangle, tan theta is 9 divided by 12. So, you can find out the value of theta. So tan theta is equal to 9 by 12, that is 0.75. So tan inverse of 0.75 is the value of theta, so which comes out to be 36.8 or 9 degrees, 36.9 degrees. So this is the value of theta. That means this value is 36.9 degrees. Yeah. Now I need to find the forces in these three members, BC, CG and GF. Now what we have to do is apply the equation of equilibrium only for this part of the truss. Now, even before that, let us assume the forces in the members as tensile forces. Assume forces in the members. In the members with these three members, BC, CG and FG as tensile forces. Okay. So you know that the sign convention for tensile forces is away from the joint. Away from the joint is tension. So one by one I will write BC. So I will take like this. So this is the force. I can take it as P1. Let me take it as P1 or FBC. You can take it as FBC. Force FBC. Force in the member BC is FBC. Then GC away from the joint, it is like this. This is FGC or FCG, both are same. This is away from the joint, FGF or FGF or FFG. So those are the three forces. We will assume all three as tensile. Please note that tensile force means it will be acting away from the joint. So that is the sign convention. Compression will be towards the joint. We assume that initially all forces are tensile forces. Later, after applying the equilibrium equations and after solving the equations, if you get any value negative, the force will be compression. That's all. Now, one by one, all the three equations we can use now. Now let us first, I will take the first equation. Sigma MA is equal to 0. You take any point, any joint here and apply moment equation first. So better to apply the last free joint. This is a free joint. So sigma MA is equal to 0. I will take clockwise moment positive and clockwise negative. Like that I will take. Now, so if you do the same, now the forces, moments I have to consider for all the forces about the point E. So here, one by one we will take. First I will take These three forces I will take. This FBC will not be having any moment about A because the line of action passes through A. Similarly, this FGF also will not have any moment about A because the line of action passes through A. So moment means force multiplied by the perpendicular distance. Only you can have the moment due to this FGC force. So FGF and FBC, they don't have any moment about the point A, but FGC will be having the moment about the point A. So now this FGC, what I will do here is, I will just take the components, I will resolve them into two components like this. So this is FGC, so this angle. So this angle we have to compute now. So that means this angle I need, this angle or this angle, any one. So if you, okay. So if I get this angle and this angle, they will be equal. From the diagram you can see. So this angle will be this distance divided by this distance. Is it not? So otherwise, if this is theta, we can calculate like this also. If this is theta, this is 90 degrees. This becomes 90 minus theta. We'll do one thing. So I need this angle. So this angle can be found out by taking this BG divided by BC. So BG value, of course, you can find out BG value because this theta is, we know that it is 36.9 degrees. So this is 4 meters. Therefore, this BG you can calculate. So we should be very careful here. So tan 36.9 degrees is equal to, opposite side is BG divided by adjacent side is opposite side is BG, adjacent side is 4 meters. So therefore, BG will be equal to 4 into tan 36.9 degrees. So tan 36.9 into 4, 3 meters. So it will be 3 meters. Okay. So this will be 3 meters. Now using that, I think we can find out this angle. So this is 3 by 4. Once again, I think this is 36.9 degrees only. So tan inverse of 3 by 4. That is tan inverse of 0.75. It is 36.9 degrees only. So that means this angle is 36.9 degrees. Therefore, this will be FGC cos 36.9 degree, and this will be FGC sin 36.9 degree. Now, I am calculating moment about the point A. When I am calculating moment about the point A, moment due to this as well as moment due to this, I have to compute. So this force is acting at a distance of 4 meters from the point A, whereas this force is acting at a distance of 3 meters. So this BG is 3 meters. We have calculated here, BG is 3 meters. So now the moment will be now, this is giving a clockwise moment. So clockwise moment is positive, that I can write FGC sin 36.9 degree into distance is 4 meters. This is clockwise, therefore it is positive. And this force is also giving a clockwise moment. So plus, so you have to take like this. To come to A, I have to rotate in the clockwise direction. So plus FGC cos 36.9 degree into distance is 3 meters from the point A. So for horizontal force, distance is vertical. For vertical force, distance is horizontal. So this is into 3. Then I have to take the moment due to this 4 kN force also, which is anti-clockwise. So minus 4 into 4. Minus 4 into 4 is equal to 0. That 60 Newton will not give any moment because it is passing through the point A. Now from this, I think you can easily calculate the value of FGC. So you just calculate the value of FGC. So FGC into, so this is this plus this 4 sin 36.9 degree. So 4 into sin 36.9, you will have some value, plus 3 into cos 36.9 degree, plus 3 into cos 36.9. So which is equal to 4.8. So this is 4 FGC into 4.8 minus 16 is equal to 0. 4 into 4 is 16. From this you get FGC as 16 divided by 4.8. So which is 3.33. 3.33 kilonewton. So we are getting FGC value positive. Since it is positive, we say tension force. Initially we have tension, therefore the answer we got positive, therefore it is tension force. So one force we got now. So FGC, the force in this member we have obtained now. Now the second equilibrium equation is sigma fx0 and sigma fx0 we have to use now one by one. So let me take the second equilibrium equation. Sigma fx is equal to 0 towards right positive, left negative. This is the sign convention we can make use for the x direction forces. Now once again you consider the right side, this portion only. I will write the equilibrium equation in the x direction. So FBC. Now what I do here is I have got the value of this force now. Now here what happens? These things, okay. Better you don't show this because you may get confused. Actually, it will be like this here. It will be like this. It will be like here, and it will be here. So when you are writing about this right part, this is not seen. See this joint C and joint F, they are not seen now. Okay. Now sigma fx0 if I apply only for this, so you have to consider only this and this. You need not consider these two members because here whatever force is there in this direction, same thing will be there in this, they will get cancelled. Similarly, whatever will be there here, same thing will be there here, they will get cancelled. Okay, you need not consider these two members. Only whatever members are intersected by this section, only those two members you consider. And any forces are given, external forces are given in x direction that you have to consider. Here, that means in that case, so I am taking towards right positive. FBC, it is like this, so I have to take negative. So minus FBC, I have to write. And here, please note that I have to take this. I have to take this. Don't take this one because I am writing sigma fx0. So this is also negative. Minus FGC cos 26.9 degrees that I have to take. Then coming to this, what happens? I have to resolve now. Similarly, whatever I have resolved here, on similar lines, I have to resolve this also. This FGF force I have to resolve. If I resolve this FGF force, the horizontal component will be like this, vertical component will be like this. So here also this angle. So please be careful here. This angle is 36.9. So this angle also we need. So this angle actually we need that angle also. If you want this angle, how to calculate that angle? This will be this distance divided by this. This is 8 meters of course, but this one we need to compute now. So because I need this angle, how to calculate that angle? You have to think. So how to get that angle? Okay, otherwise you can do like this. This is 90. This is 36.9. And this is 36.9. This will be 90 minus 36.9. So 90 minus 36.9, which is 53.1. This angle is 53.1 degree. Okay. Then you know that this is 36.9. This is 36.9. This is also 53.1 degree in this triangle. So 53.1 plus 53.1 plus 36.9. So remaining is this side. 180 minus of that. That means it will be 53.1 plus 53.1 plus 36.9 plus so 53.1 plus 53.1 plus 36.9, which is 143.1. So I have to deduct that from 180 degree. you will get 36.9 only. So this angle is 36.9 degree only. That means if you resolve this, since this is 36.9 degree, so this will be FGF cos 36.9. This will be FGF sin 36.9. So you should be very careful in the resolution. Now I have taken this now. This is over. Next I have to take this one. So it is also acting towards left. So it is minus FGF cos 36.9 degree is equal to 0. So this is the equilibrium equation. Here FGC value, you know, this value is 3.33. The other two are unknown. So you can just call this as equation 1. Now the third equilibrium equation is the vertical forces equation, sigma Fy0 toward upward positive, downward negative. Once again consider this part of the truss. Whatever upward forces are there, those forces you write upward positive, and downward forces you have to take negative. So this 4 is downward, 6 is downward. What I will write? -4 -6. I will directly write. Then this of course is horizontal. Here among these two I have to take this. So this is upwards plus FGC sin 36.9. And for this FG of course, this I have to take minus, because it is downwards, minus FDF sin 36.9 is equal to 0. So this is the equation. Now here FGC value, you know, it is 3.33. Now I think you can find out FGF here, because this is known. This is minus 10, minus 4 minus 6 minus 10 plus of course 3.33 into sine 36.9, which is 1.999, that is 2, almost you can take it as 2, minus FGF sin 36.9 is equal to 0. So from this you can just calculate FGF as FGF will be equal to minus 10 plus 2 means it is minus 8 divided by sin 36.9. You can please note that this is negative value. So 8 divided by sin 36.9, which is 13.324 minus 13.324 kilonewton. So since the forces are given in kilonewtons, external forces, internal forces developed also will be in kilonewtons. So we have got here negative. This is one important thing. So compression force you have got. Initially we have got tension force, but since you have got negative value, so it is a compression force. Now we got the force in the member GF also. So we got the FGC over, then GF also is over. Only we have to find out the force in the member BC now. That can be found out by substituting for FGF in this equation 1. So substituting for FGF in equation 1. So FBC will be equal to, if I bring this FBC to RHS, this minus becomes plus. These two I will write it as it is. So it is minus FGC is 3.33 into cos 36.9 minus FGF is once again minus. Be careful here. So this becomes minus of minus. Minus is there here. FGF is minus 13.324. So minus into minus it will come cos 36.9. So if you simplify this, you will get the value of FBC, force in the member BC. So it will be now, I will take minus 3.33 into cos 36.9, that is the first value. Then minus to minus becomes plus 13.324 into cos 36.9. So it will become 7.992 kilonewton. Since we have got positive value, it is tension force. tension force. So that means in the member GC it is tension force, in the member GF it is compressive force, in the member BC once again it is tension force. So this is how we have to compute the forces in the required members. By using method of sections, we can find out maximum 3 unknown forces by taking a section which cuts the members in which the forces are asked, and also by considering one side of the section and by applying the equations of equilibrium, 3 equations of equilibrium, maximum 3 unknown forces can be found out. So this is how we can find out the forces in the members of a truss by using method of sections.